Hi all, I'm Dr. Leonie from UMK Field. Today we'll be covering Chapter 2, Inequalities. Before we start, it's good that we rehearsal back last week's content. It's about how to solve the polynomial equations and also partial fraction decomposition. There will be a total of 5.1 until 5.9 questions. We will do one by one. We start tutorial 5.1. Here, we only select one of the question, this one. When we look at these polynomial equations, we found that the index is power of 3, which means that we might have 3 solutions. Let us check whether we can pull out some of the factors. We are given 6x power of 3. It seems that x can be the first factor we can bring out. And then we can conduct the quadratic factorization from the bracket there. Later on, we can have the answer x equals to 0, x equals to 2 over 3, and x equals to negative 1 over 2. Here, we have 3 solutions. If you want to check for question A, B, and C, you can find the slide here. Let's go to tutorial 5.2. There are 2 buses are transporting a football team to a game that is 120 miles away. The second bus travels at average faster 10 miles per hour, and since it's faster, so it arrives 1 hour sooner than the first bus. For this question, we want to turn the text into a picture, then it could help us how to solve it. So we have 2 buses, bus A and bus B here. The distance is 120 miles. Because this involves the speed for the bus A equals to the distance 120 miles divided by the time taken by bus A. Then the speed for the bus B, we don't have much info, but we know that it's equals to 120, same distance, divided by time taken by bus B, or equals to TA minus 1, because it's faster. So from this general relationship, it will bring us to solve the question. We can find the average speed for each bus later on. So we can go through the question appear here to know how to get the answer. At the end, you're going to get the first bus speed is 30 miles per hour, and then the second bus is 40 miles per hour. This is bus A, and this is bus B. When you compare these 2 numbers, 40 and 30, yes, both of them have 10 miles per hour difference, as stated inside the question. Let's move on to tutorial 5.3. 5.3 is about the partial fraction. It means that when we are given a partial fraction, there will be 2 cases. Case 1, decompose 1. When we have the composed one, it's quite difficult to decompose it. Difficult. In other case, when you're given already decomposed, it's easy to compose it. For our case, we want to do the decomposition, the difficult one. I will skip through all the description here. We'll move to the question itself. We are given the composed partial fraction. So it expressed in x minus 11 divided by, we have the first factor and the second factor. When we look at the factor, they seems to be linear factors. Means that if you draw it inside the graph, it is a straight line. So how to solve that? Since it's linear factor, it's easier. So we can use the general expression to describe the relationship between the composed versus the decomposed. Since we have this one, we want to merge them together into a composed again. So we times the same factor for both. Okay, then from here you're going to expand it, and then you're going to tally the x and constant. This is the general step how you can decompose the partial fraction. Details, check the next slide here. The first, we form the general expression, and then we create the same nominator. After that, we're going to compare one by one. To compare the x and also the constant. This comparison will help us to find value A and value B. Once we have the value, we're going to replace into the general expression here. So at the end, this is our answer. Sometimes we are given a partial fraction that is quite complex. For this case, tutorial 5.4 is expressed in a non-linear partial fraction. It's more complicated. Why? Because when we have a non-linear, the general expression at the first step is like this. We need to separate into A, B, and C. Okay, this is the A, this is the B, and this is the C. Does it look more difficult? Yes. Why? Because later on, you're going to make the numerator equally at this step here, and then it's going to expand. It's going to take more effort to find what's the value of A, B, and C. Once we have A, B, and C, we're going to replace it into here, B and C. So the final answer is the white color box here. Move to next one. Okay, we're going to skip this one. We go to the content for this week, inequalities. Inequalities, we can identify inside one mathematical statement using this symbol. We either can see this greater than, less or equals to, greater than or less than. I'm going to skip some of the slides here. When we have a set of inequalities, we can define the final answer x from where to where. How can we tell the story about the x? We can use three ways. The first way is the interval notation, the set notation, and a geometric representation. This one suitable for kids. This one would suitable for you, and this one is more understandable by a professional. We'll look at the next question. How can we express interval notation from set notation and a geometric representation? We're going to skip through this one. We're going to the next tutorial question 5.5. Now we are given an inequality statement, mathematical statement. We rewrite again. We're going to expand it in order to make things organized. We will pull all the x's to the left hand side and all the numbers to the right hand side. Be careful, when we change the direction by divide or times, we need to change the direction of the inequalities. This one. Now we have x is greater than 4. We're going to express it in three ways. The first way is the interval notation, IN, the set notation, and also geometric representation. Okay, for the interval notation, it is expressed using the bracket. X is greater than 4 and it can go beyond to any positive value. For the set notation, we just write x is greater than 4. Easy, right? And for geometric representation, 4 is here, 5 is here. So since it is greater than, we will have a circle and we will draw an arrow saying that it's greater than. Okay, we'll move to the next slide here. Tutorial 5.7. For this case, it involves the non-linear inequalities statement. It's a bit different when we want to define the range. So we rewrite again. So for this case, we're going to form quadratic inequalities. For this case, when we want to define the range, there are two ways. The first way is a graphic way, Another way is the table way. Let's use the first way, the graphic way. In general, we can express our quadratic equation. For this case is 2 here, 3 here, this is 6. Since it is less than 0, means that we're going to cancel off everything above here because we want something that's less than 0. So our x will be between 2 and 3. Okay, the table's way. The first one, we write the first factor, the second factor, and the last one is the total factors. Okay, now we have 2 here, we have 3 here. Let's say here is value of 4 and here is value of 1. So we check, when x minus 2 we replace with some value 1.5, it creates a negative value. When we replace something 2.5, becomes positive. We replace 3.5, it becomes positive. We replace 4 and above, it becomes positive. Okay, next, x minus 3, when we replace one number negative 1.5, we have negative. We replace 2.5, we have negative. When we replace 3.5, we have positive. We replace with 4.5, we have a positive. Now we're going to sum it up. Here, positive. Here, negative. Here, positive. Last one, positive. Since our inequality is lesser than 0, so we pick something is negative. So still between 2 and 3, x. So same as the graphic way. We'll move on to tutorial 5.7. Try it yourself. TIY, try it yourself, okay? I draw a smiley face for you to make a cheerful moment. So there's a details will be shown here. For this problem, you want to start with this stage. We want to cancel off the right hand side. So left we add the term here, and right we add the term here. So later on we're going to form the inequalities at this level here, and then lastly we're going to get the inequalities in the factorized form here. Then if we draw inside a graphic, it's quite difficult, so we're going to use the table to find the range. Since we want to have everything is greater than 0, so later on we're going to choose here positive. Yes. Here positive. Yes. Okay. Tutorial 5.9 and 5.10. Okay, looks a bit small here. This is taken from the book, the textbook, the UMK textbook, UMK Life Mathematics. If you don't have it, it's okay, you can leave it. We will see how later on. If you have the textbook, what you need to do is to design a similar, okay? You are not solving the problem. You redesign the question. If you want an easy redesign question, let's say the question mentioned about RM50, you just change to RM20 and then you solve it. Okay. Okay, tutorial 5.11. In case you have the photo step tutorial from Dr. Leonie, then you do this one. We'll see how, because at this moment many things seems a bit kalam kabut. Anyhow, this one, yes, go to tinyurl.com/mathematicsbp and fill in the form before this Wednesday, that's today, 5 p.m. Okay, this will be your attendance. Okay, thank you all. Bye.